Hello everybody, Aiden, lead instructor and mentor here at NGT Academy, here to discuss the Node MCU ESP8266 Microcontroller. It's a very powerful and very popular microcontroller for enthusiasts. It boasts a built-in Wi-Fi app and of course full support for the TCP/IP suite. Today we are going to learn how to turn this very versatile microcontroller into a device that you can add into your Wi-Fi pen testing kit. So if that piques your interest, keep watching because we're about to hit it. All right, I'll see you guys in the lesson. Bye.
All right, let's go ahead, just jump right into it. Welcome to the introduction to the ESP8266 microcontroller. This microcontroller, basically, it looks like it plugs into things. Well, that is correct. It does. This is very popular for Arduino-based projects and also Raspberry Pi projects that have the GPIO support. This has been around for quite a few years, and it's extremely popular for IoT based projects. So in this case, we are going to use this as a standalone product, and we are going to essentially make this into a pen testing tool for Wi-Fi. Essentially, what we're going to do first and foremost is download the firmware package, run the firmware flasher, and plug in the device. We're going to then identify the COM port that this device will need in order to communicate with your host system in order to upload the firmware. After that, you don't need to have it plugged in, or just you would need to have it powered, but you would not need to have it plugged into your computer, if that makes sense. Then we are going to connect to the ESP8266, which is going to have its own access point. We're then going to go ahead and access the management console, and then we are going to do a couple exercises like setting de-auth frames and then fake access points. Again, the SSID for this access point is pwn, and the pass is de-author. So in this case, let's go ahead, just get this show on the road, and let's go ahead and do that by downloading the firmware package. Okay, so I did a thing to make it easier for you guys rather than going all over the internet. I have provided the link for you guys where you can download this package over here. And basically all we really need to do is download drivers upload tool firmware. If you go to download this and it is no longer, these two are no longer here, don't worry about that. I'm just going to go ahead and download this tool right now. And I will have this done in a moment. All right, once this package has been downloaded, all we have to do is decompress it, and it is as simple as basically just getting your Explorer window over to your downloads or wherever you download your files to and decompressing this. Now here it's going to be called drivers upload tool dash firmware. We're just going to need to extract all into the same directory. No need to do anything fancy. Let's go ahead and extract the tool. From here, all we really got to do at this point is go through a couple procedures. Well, essentially two, maybe. Essentially what we need to do is go to CP210 Windows drivers, so we are able to communicate with this to the microcontroller. Now, you have two choices. You could either utilize the x64 or x86. If you don't know the answer to this, chances are the answer is going to be x64. Most computers these days are x64 or 64-bit. And you just go ahead and just double click that. You can just go ahead and say yes to this screen over here. And you should see a installer for welcome to the CP210X USB to UART bridge driver installer. All we got to do is press next. And let's go ahead and accept this. All right, and let's go ahead and finish that. Okay, what this allowed us to do is basically provided a driver so your computer could initially make a conversation with the ESP8266. Now, from this point on, it's rather straightforward. All we really have to do now is go up a little bit and execute the flash download tool here. And then from there, we would need to go ahead and upload the firmware to the device itself. So all we have to do is just basically execute this tool, execute this, and you're going to be given this prompt like so. Okay, the chip type is of course 8266 ESP32. This particular tool works with a good range of the ESP products, which are very popular microcontrollers. So 8266 is what we want, and we are going to use the develop. And let's go ahead and press OK. And then boom, here we go. We have ourselves, let me move this over here so it's a little nicer. And then now we have this little interface. Okay, so we are going to go
and type and upload this ESP8266 bin, and here we go. At the start of address is 0x0000. 5 zeros, 0x, and then 5 zeros that goes along there. Okay, 40 megahertz is fine for the speed, SPI speed, and QIO mode is fine, but we also need to identify which COM port that we are utilizing. So this is the part where most people probably get a little lost. So what you're going to need to do is type in your device manager. And here in device manager, there should be a place called ports and comms, and here you go. All right, so let's see, standard serial over Bluetooth link. Nope, that's not it. Standard serial over Bluetooth link, that's not it. So it looks like we are using COM3 for this, Silicon Labs CP2 10X USB to UART bridge, and I am not going to unpack that because a lot of those terminologies don't usually come up very often. So we're going to go put COM3 as verified in the device manager, and we are going to go ahead and start this bad boy, and you will see that your particular microcontroller, there is going to be a blue LED light, and it's going to go a little crazy there. And once it is done, it will stop flashing. And all honesty, guys, it probably took like 2 seconds. So we're all set. So we are now essentially on step 6, which means that we need to connect to the ESP8266 access point, which is going to be pwned, and the password is going to be provided down here in the very left-hand side. And essentially all we need to do is connect to Wi-Fi. And what is going on here? We have no Wi-Fi networks in range. That is weird. So I'm going to go ahead and do this. Pop that. And looks like our device is not listening to us. So what I'm going to do here, okay, so on the fly troubleshooting, I'm going to go ahead disconnect the ESP8266 from the USB controller, and I'm going to wait about 5 seconds. 5, 4, 3, 2, 1, and reconnect the USB micro USB to the 8266 microcontroller. Okay, give it a moment. There should be a blue light on your microcontroller, and we are going to attempt that one more time. And let's see here. Still nothing, and we're going to wait until this program or this application is done here. So we'll give it another moment. There you go. Looks like we just were a little bit impatient. There should be an access point that comes up, and that is PWEND. And let's go ahead and connect to this. And the password is going to be de-author, DEAUTHER. And we are going to say next. And it should be connecting right about now. Well, okay, we'll give it a little bit more time. It is connected. Of course, there is no internet because it doesn't provide internet. You're directly connected to the access point, which is not connected to the internet, so that makes sense. And what we're going to need, 92.168.4.1 is what we're looking for. And you should see something that looks like this. That's right, everybody. On that small, tiny microcontroller there, what you will see, that's right, everybody, on that tiny little microcontroller is actually a web server. And as soon as you are done reading all this information, go ahead and say, I have read and understood that information there. Okay, now here you guys go, take a look. Here we have a management page for the 8266 de-authing tool. And as you can see, it has scanned my local area around me, and here are all of the access points available to me. Of course, the ones in green are the closest, and the ones in yellow are pretty far away. Again, yes, this is going to be pretty limited because of the fact that the antenna on this microcontroller is extremely small. So yes, you're going to either need to create or use a different antenna or integrate a different antenna. All right, so first order of business, let's go ahead and talk about setting de-auth frames. And basically what setting de-auth does is this is basically a exploit against a vulnerability on some older access points that are out there that don't require authentication for management frames. Okay, great. So what we're going to do is send de-auth packets, and I'm going to go ahead and send de-auth packets on over to this one because that is my personal access point that I'm using for my house. All of these other ones are not within my control. So as an individual of high outstanding morality, I cannot attack anybody else's. Now, to show you that this is working, I am going to go ahead and open up a Kali Linux window. All right, now that we're in Kali, let's go ahead and let's go ahead and bring up the interface in Kali. 192.168.0 or 4.1 is what we're going to be looking at. And what do you know, with the wonders of networking, we now have ourselves a interface here that we can manage the ESP8266 device. And what do we know here? Looks like we have a lot of functions that are available to us, and one of the functions that we have is essentially we are able to scan local access points around our area. Of course, the ones in green or with the lower RSSI, receive signal strength indicator. Again, that's received signal strength indicator. The lower the number, or actually, you know what? I said that backwards. The larger the number, the better the signal. Of course, -78 is going to appear orange. -16 is going to appear green. Again, larger the number, even negatives, is the better the signal. Now, I am going to go ahead and attack D76E. That is my home Wi-Fi access point. I am not going to attack anybody else's because, well, that just doesn't, it's not very ethical to attack anybody else's networks. Now, what we're going to do here, guys, is we are going to send some de-auth frames on over to my access point here. And what this does is we are attacking a vulnerability that is present in many wireless access points that are out there that don't require authentication for management frames. And that what that will do is kick off devices from the access point. So I am going to go ahead and start this by going into attack as soon as I show you guys that we are going to verify that this is working, or verify this works by using Wireshark. That's in here. But before that, we have to place our card or Wi-Fi card into promiscuous mode that's connected to our Kali virtual machine. So here, if I do ifconfig, I do have WLAN 0 up and running. All right, fantastic. So I'm going to go ahead and do airmon ng start WLAN 0. And there we go. We now have a promiscuous card, or a card in monitor mode. I believe that's actually more correct terminology, monitor mode. Promiscuous is something you would say about a NIC or network interface card. And it looks like it's in monitor mode right there. Perfect. And let's go do another ifconfig. Perfect. It's up and running. Now, what we can do is open up Wireshark. And we are going to listen in on, oh, well, look at me there. I messed that up. Let's go ahead, back to WLAN 0, start that. And then let's go ahead. There you go. And what do you know? There are a bunch of management frames being broadcasted all over. Okay, let's go ahead and go over to attack, and let's go ahead and start this attack over here. And sooner or later, you are going to witness or essentially see some de-authentication probes moving around the network. They're usually around 48 bytes here. So we'll give it a second. Actually, let me bring my Wi-Fi adapter closer to the ESP8088 or 8066, I should say. Give me 1 second, guys. I'm just moving stuff around. All right, here we go. There you go. Now it's a lot closer. to my card. Now I see a bunch of de-authentication frames. What this is doing is kicking off my wireless devices from the network itself right here, and the proof is right here, guys. I'm going to stop this, and we have a bunch of de-authentication frames moving about against here, not that one, de-authentication frames right there, and this will kick off anybody that's on this access point. Kind of malicious, kind of cool, kind of interesting. And why would you use this? Well, if you were doing a pen test and you want to capture somebody's WPA2 handshake, kicking them off would force that handshake to negotiate again. So that is one reason why you'd want to do this. Or if you just don't like your next door neighbor, you can disconnect their appliances or disconnect their stations from their access point. All right, so let's go ahead and do another cool thing here. And what we can do, let's go ahead and stop this. All right, I'm gonna make this a little bit larger. One other thing is, let's go ahead and see about SSIDs. Now, here we go. Let's go ahead and I think this is kind of funny. The never gonna give you up, never gonna let you down. This is super, super cool. I really like this, but this is a way to clone SSIDs within your environment, or do whatever you want. Okay, you can change these up, you can delete these and create anything you want. So we're going to go ahead and just go with the defaults here, and we are going to start beaconing around here. All right, so we're going to do a bunch of beacons, and we're going to go ahead and continue without saving and start recording. WLAN 0, there you go. All right, and there we go. We now see some more frames moving around. And let's see here. Let's see what we got going on. All right. Okay, here are some broadcasts going out. And we are looking for those SSIDs that we were looking at. Ah, there we go. Okay, actually, there's a better way to show you guys this. Let's go ahead and take a look over our networks now and see here. Well, never gonna tell a lie. Okay, actually, you know what? Maybe this is there's a better way to do this. Let's do it this way. Let's use AirMon to show you guys that this is showing up. So what I'm going to do here, so let's go ahead and use arrow dump WLAN 0. And let's see what exactly is picked up from, there you go. Now we get a better view of the network or the local area here. Never gonna, yeah. It's not in order, obviously, but you guys can tell right here that now you have a bunch of fake access points on your network. Okay, I'm not gonna go too much in detail, but basically kind of fun stuff for this microcontroller. You can use this pretty much in a good deal of projects that are out there. You can connect this microcontroller to a Raspberry Pi. You can connect it to an Arduino. Actually, this microcontroller, the ESP8266, is used quite a bit on IoT devices or integrated within IoT devices for these kind of management scenarios here. So, hope you guys learned something. Hope you guys had a lot of fun. This has been Aiden with NGT Academy saying, hey, come back next time. We have more cool stuff to show you. All right. Talk to you guys later. Bye.
Jacob Hess here. Thank you for watching the video. I hope you really enjoyed it. And I'd also like to remind you, if you're truly serious about your career in information technology, then be sure to check out our IT engineer training programs at www.zerotoengineer.com.